0. This F1, it is nothing but here the output. XYZ as nothing but the input, right? So here 3 variables are given. So for that, based on how many combinations are there? 7 combinations. For that, this output is produced. Okay, so this truth table it is given. So based on this, we have already seen that how to find out the SOP form for that. As wherever the 1 will be generating as output, we are going to consider those terms only, right? So when we are considering the SOP form, we are going to consider the terms where the output is getting 1, right? So in this truth table, what we have seen, this term, and this term. These 3 terms are producing the output as a 1. So we have generated a form here, right? So this form we have generated based on the corresponding mean terms, right? So those mean terms are these, and based on that, we are getting this particular form. Always mean terms are represented with this summation sign. So this is written in terms of this function. This is written in terms of this way also, and this is also written in terms of summation of 147. Summation of 1 first term. Here you can see 0, 1, 2. According to directly also you can calculate. This is the term that representing the decimal value 1. This is the term that representing the decimal value 4. So directly also you can calculate once you understood this particular topic, right? So based on this again, with this concept, we are going to see what is POS, right? SOP, it is nothing but the group of product terms. What we have done, you can see in the final expression. See, x bar dot y bar dot z plus x dot y bar dot z plus x dot y dot z. Means this is nothing but the product, right? Okay. So this is the group of product terms, and those product terms are ORed together. ORed means we are taking the summation of those product terms. So this is the SOP form. Okay. Now next it is the POS form. POS, it is nothing but known as the product of sum. Okay. It is the reverse of SOP. In the SOP, we have used the min term. In the POS, you have to use the max term. Okay. So the product of sum expression is a sum term, that is the max term, or several sum terms, max terms logically multiplied and together. Now here you can see few examples. Students, am I audible?
Yes, ma'am.
Okay. So here you can see the example of POS expression. See this example, x plus y bar, one bracket is given dot, x bar plus y, this bracket is given dot, x bar plus y bar. Now here you can see how many terms are there? 3 terms, and those are separated with this dot, right? X plus y bar, this is one term, x bar, this is one term, and this is. So there are 3 terms, and those are multiplied, right? So always the POS, product of sum, is a group of sum terms, ANDed together. Okay. So ANDing of those sum terms, it can be done in the POS form. You can see AND means product, OR means sum, right? So these are the expressions that indicate the POS expression. Again here, this is one term, this is one term. Those are ANDed, multiplication. Okay, so these are all the POS form. So have you understood what is how the SOP expression is, examples of this SOP expression and POS expressions? Have you understood this part, students? What is actually POS expression it indicates? Okay, I will just give you few examples. You have to tell me the output, whether it is a SOP or POS form. Okay. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, tell me students whether this is the SOP expression or POS expression.
SOP.
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 Right, because this is the sum of product terms. This term, nothing it is given. A, B, C means this is nothing but A dot B dot C, right? And there are two terms are present. Addition of those two terms, that is nothing but the SOP form. Which form is this?
Product of sum.
Product of sum.
Okay, so this is the product of sum. Here you can see there are two terms, but in one there are two literals. In another term there is only one literal. Okay, so here dot it is there. That is nothing but the, here in the POS always we take the group of sum terms, right? Group of sum terms, but here only one sum term it is there. In the another term there is only one literal, one variable is present. Okay, but those are ended together. So this form, that is the POS form. In this way, it is not compulsory. In sometimes, in some of the expression, in some of the logic functions, not all the literals are present. A plus B. Which form is this?
POS.
POS.
POS. Okay. Which form is this? Last one.
SOP.
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 Okay. So you understood the POS and SOP expressions, right? Okay. Now see here for the next part. Same example that we have taken for the SOP, the same truth table here again it is there, but now for that truth table we have to convert into POS form. Okay, so this truth table, for that in the previous part we have seen how to convert into SOP. So whenever we have to convert into SOP form, in that case we have to consider only the output as a 1. But in the POS form, it is the reverse case. In the POS form, you have to consider the output, wherever you will get in the truth table, the output as a 0. Those terms you have to consider, right? Those max terms you have to consider. Now, in this particular truth table, wherever you are getting 0, those terms you have to consider. So, there are how many combinations those are producing the output as a 0?
5.
5 combinations, right? So in the POS term, exactly reverse of SOP, you have to check where the output is getting 0. Those combinations you have to write it. 0, 0, 0, that is generating, that is nothing but the decimal 0. Then 0, 1, 0 means 2. Then 0, 1, 1 means 3. Then 1, 0, 1 means 5. And 1, 1, 0 means 6, right? So there are total 5 combinations. Those are producing the output as a 0. So here you can see the following 5 combinations of variable produces a 0, right? Now, what is the next step that you have to do? You have to write in that POS form. How you will write? 0, 0, 0. Whether 0 indicates bar or 1 indicates bar in the max term?
1.
1. Now here you have to consider the max term. Min terms are considered in the SOP. Min terms means, min terms are nothing but 0 is represented as a bar. In the max terms, here it is nothing but the 1 is represented as a bar. Now, how you will consider max terms? Their corresponding max terms are x plus y plus z. Say, here max terms, this is nothing but again, we have to consider the plus. Why? Because that is the POS form, product of sum. So you have to take the, take the addition of those variables, right? So here you can see instead of product, here the addition is taken because this is a POS form. So for this particular term, 0, x represents what? It represents 0. This y also represents 0 and z also represents 0. Okay. What this represents term? This is the first term. This you can see 0, 0, 0. 0, 1, 0, 0, 1, 0. How it is there? X plus y bar plus z. So 1 indicates bar, right? So 0 plus 1 plus 0. Then this will be 0, 1, 1. Okay. Instead of dot, here sum, and instead of complemented form for 0, complemented form for 1 you have to use. X bar plus y plus z bar and x bar. So corresponding max terms are written. The corresponding max terms representing these 5 combinations. Okay. So always you have to remember this table. Always this table you have to remember, students. This table. If you know this, you can write the min terms and max terms according to that. Here what we have seen, 0, 0, 0, x bar, y bar, dot z bar. But now I have to write the POS form for this, because this combination is producing now the output is as a 0. And we are considering those terms where the output is getting as a 0. So how you will write that term? X plus y plus z, right? It is the reverse of this. Here plus it is used and no bar. Bar it is representing for 1. Okay. So accordingly for this, after that you have to take the AND of these max terms. So taking the AND of these max terms, you will get this particular expression. Okay. Means indirectly that is nothing but M0, M2, M3, M5, M6. Capital M represents max terms, right? And what this 0 represents? This 0 represents the decimal value of that particular combination. That is 0, 0, 0 means 0, right? 0, 0, 0, 1, 0, that is 2. So see, if you understood this particular concept directly also you can write it. Okay. Now this is just for understanding all the stepwise here it is written. F1 of xyz. So this is a function of 3 variables. Okay. Finally, you have to write it completely, the expression. This is a function of 3 variables. And what this symbol indicates, this is the pi. Max term also always represents pi. And here these terms are written 0, 2, 3, 5, 6. This is known as canonical form. Okay. This form is simple to understand. Okay, where all the expressions are considered in terms of min terms and max terms. Okay, so based on this, I will take one example. Have you understood this concept, students? How this is getting? Is there any doubt in the now SOP and POS? What we have written directly, I will tell you. I will tell you shortly, directly how you can write this particular form. Okay, just wait. Okay, we have seen this truth table. I will write it again, x, y, z, right? And that is the function that is given here. Now for this, okay, for this, output is 0, 1, 0, 0, 1, 0, 0, 1. Okay. Now for this particular table, this is the output. Okay. So what we have done, the same truth table now just that is given in the PPT, this is the same truth table. What you can see now, suppose from this truth table, I want to convert this truth table in terms of SOP and POS form. What I will do, okay, directly first, I will write here in terms of, as you know that this decimal representing this, that is 0, right? For this term, what is the decimal? 0, 0, 0, 0. Okay, at this particular side, I will write. Okay, so these are the decimal values I have written over here. Okay, now for this, I want to first will convert into SOP form. Okay, directly what I will check first, I will check wherever the output is producing as a 1. Those terms, those combinations we have to consider. Now, which combination you can see where the output is getting 1? That is this combination 001, right? Means this decimal 1. So this is the SOP, right? This term is also required for SOP and this combination is also required for SOP as those are producing 1, right? Now, what I will write y that is nothing but the result. Okay, y equal to which sign is required for SOP? Summation, right? Summation of what? M. Mean terms represent small m. Now what I can do, I can directly write what is the decimal representing this value? 1. So 1, right, comma, what the decimal representing this value? 4.
4.
Okay, what is the decimal representing this value? 7. So directly I can write it, right? Okay, so this is the form that you will be getting indirectly through finding all the. Now actually if it is expressed, if it should be required in terms of expression form, in that case you can write that another form. Okay, but if it is required directly, if you want to find out the canonical SOP form, so this is known as canonical SOP form. Okay, this short form that is known as canonical SOP form. One more way how to write it: M1 plus M4 plus M7, right? Now I want to convert, this is done. Now want to convert into canonical POS form. Okay, so how to convert into POS? Now for POS you have to consider zeros. The combinations, those are producing 0 as output. Okay, so directly you can write now y equal to, which sign it is used for POS?
Pi.
Pi, right? So pi, for here you have to consider capital M. Now just write the decimal representing these combinations. Okay, that is 0, then 2, 3, 5 and 6, right? So this is the POS form, that is the canonical POS form. Or you can write M0 plus, sorry, this should be capital M, M0 plus M1 plus M3 plus M5 plus M6. Okay, yes. Sorry, yes. Here multiplication is required. Okay. Okay, here multiplication is required, so dot is required. Because this is a POS form, product of sum, and all those terms are representing sum terms. So we have to take the product of those terms. Here we have to take the sum of product terms. Okay, got it, students? Okay. Okay, so with this, how to conversion between canonical forms, from one canonical form into another canonical form. That is how to convert from SOP to POS and POS to SOP. Okay, so to convert from one canonical form to another, interchange the symbol. Just a minute. Okay, and list those numbers missing from the original form. Now here what you can see, f, this is a function of 3 variable x, y, z, where pi of 0246, this is given. 0245, this is given. Means this is the POS form, right? Pi represents, means it is a POS form. Now you have to convert into SOP. What you can write? You know that the output, those are producing 1. Other output, remaining output will be producing 0, right? So what you can write? The remaining terms, those are nothing but the min terms, as if those are the max terms. Max terms always producing zeros, means the remaining terms, those will produce 1. Those are known as min terms. So directly also I can write summation of what are the remaining terms here. You can see 1, 3, 6, 7. Means those will produce the output as a 1. Okay. For this same also, see students, as now just now we have seen this particular example. In this, if this particular term, if these 3 terms are producing the output as a 1, the other terms are producing, so means if I am getting this particular SOP form, I can directly write the POS form also, right? Because if the output is not producing 1, means it will be producing a 0 output, right? Because we have already written for this form, so directly I can write this particular form. You got this concept? If the output is producing 1, am I audible, students?
Yes, ma'am.
A and B division both, is there any problem? A division? Okay. So what I want to say, conversion, how you can do it from SOP to POS. One canonical form, if you know that, you can write another canonical form simply by converting into, just by interchanging the symbol. Okay, just by interchanging the symbol and just by interchanging the numbers, symbol and numbers. Here you can see these 2 examples are given. Pi of 147 means these are the max terms. Now these max terms are producing the output as a 0. So the remaining terms will produce the output as a 1. So these are the min terms are written over here. 0, 2, 3, 5, 6. So directly here, there is a process to convert. That also I will show you. But this is the short way how we can convert from one canonical form to another canonical form. You have to just interchange the symbol and you have to list down the numbers. Those are missing in this term. That will be represented in another term. Okay. So for that also I will show you how actually this conversion it happens. Okay. Now directly I will show you the notes for this particular part, another part. Okay. Is this screen visible to you? This copy of notes is visible to you?
Yes.
Okay. Now see over here, we have seen you can go through the notes, students, each and every point in detail here it is given. Okay. Sum of product, product of sum. Okay. Now the next part, that is what is meant by standard SOP and POS. Those are also nothing but known as canonical form. Okay. What is meant by that? That first we'll see. Those are also known as min-term canonical form. Okay. See, you know that the expression, suppose let's consider this expression. Okay. F of A, B, C. A B bar C plus A B C plus A bar B C. What you can see in this particular expression? Here, this particular expression represents 3 variables. Means this is the function of 3 variables. Right? Okay. But here you can see 3 terms are present. Okay. So these 3 terms, what it indicates that in each and every term, or all the literals are present. Here also A, B, C present. either in a complemented or uncomplemented. Here also present and here also present. Means in each and every term, all the literals, those are given in the function are present. So this is known as standard form. Okay. Now here you can see this definition. If each term in the SOP form contains all the literals, then SOP form is known as standard or canonical SOP form. Okay. Each individual term in the standard SOP is called as mean term. Each term it is known as what? Mean term. Okay. In the standard SOP form. Canonical SOP is also known as mean term canonical form because all those are known as mean terms, right? Each product term consists of all the literals, is either in the complemented form or in the uncomplemented form. So this is known as the standard form because not a single literal is absent here. All the literals are present in all the three terms. So this is known as standard form. Okay. Likewise, how to represent the standard POS form or max term canonical form? See here the difference. Wherever SOP term it is there, there is a term along with that mean term canonical form. Okay. Wherever the term POS it is there, that is max term canonical form. Okay. Now, if each term in POS contain all the literals, then the POS form is known as standard POS or canonical POS. Now, here you can see this particular expression, right? A plus B plus C. See students, here this plus is not required. Here it should be dot. A plus B plus C dot A plus B bar plus C. What it indicates? It indicates that this is the POS form. This is the product of sum. So here product is required. Okay, but again in this term, all the three literals are present. In this term also, all the three literals are present. Okay, means this is the standard form, right? But suppose in few of the cases, if it is not there in given in the expression, okay, in that case, how to convert that expression into standard SOP or standard POS? Okay, so for that, now just I will give you a few more examples for that particular part. Okay, as just now we have seen different examples for SOP and POS form. AB plus B C bar. Okay, this is the SOP form, students, right? But what you can see in this particular form, this is the function of three variables, right? Why? Because here AB it is there and here C also it is there, right? So this is the function of three variables. But here in this both the terms, not all the literals are present. Here only two literals are present and here also two literals are present. Those literals either it can be in the complemented or uncomplemented form. But not all the all are present in all the terms. So this is not a standard form. This is not a standard SOP form. Now you have to convert into standard SOP form. This form you have to convert into standard SOP form. So what is the way how you can convert this particular expression into standard SOP expression? Okay, that is the part now actually we'll see. So the converting an expression in standard SOP or POS. Okay, so here you can see what you can so there are few steps for that. What you can do, just go through this definition first and we'll see the steps. Sum of product form can be converted to standard sum of product by ending the terms in the expression with terms formed by ORing the literal and its complement which are not present in that term. Okay, see, by definition maybe you are not understanding, but at the time of converting this you will understand. Now for a three literal expression with literals A, B, C, if there is a term AB, okay, in that if C is missing, then we form the term. If C is missing, only the expression contains AB. So what you will do? C plus C bar, okay, and it with AB. So we get AB dot C plus C bar, okay, and now you have to again multiply this particular bracket with this particular term. So you can expand it. ABC plus ABC bar. So this is the standard form of this. Okay. Now we'll see, first go through some steps and we'll see the examples. What is the first step to convert SOP to standard SOP? First step, that is find the missing literal. You have to first find which one is the missing literal in each product term, if any. Then step 2, and each product term having missing literals with terms formed by ORing the literal and its complement. Okay, you have to take the AND of each product term where you have to consider those missing literal. Okay, and then you have to take the OR of that with the actual term. Then expand the term by applying the distributive law and reorder the literals in the product terms, and then reduce the expression by omitting the repeated product terms. Now just go through this example. Convert the expression in the standard form. Okay, see, in this particular example, f of a comma b comma c, this expression is given. This expression, it is not in the standard SOP form. Why? Because this is a function of 3 variables and not all these 3 ABC variables are present in all the terms. Here only 2, here also 2, and here also 2 literals are present. So which one is missing here? A is missing here. Here which one is missing? C is missing. And here which one is missing? B is missing. Now you have to convert into standard SOP form. What you can do? This is the first step that is done. The next step, you have to take AND of those product term with the missing literal. Now what you can do? Here A, here C, and here B. Okay. See here, AC, you have to take the and then you have to, whenever you are taking the and, after that in the bracket, you have to consider that missing literal and its complement. But you have to take the ORing of those. So B plus B bar. Okay. Here you can see AND product term with missing literal plus its complement. Okay. Then plus AB dot C plus C bar. Which one is missing here? C. So C plus C bar. Okay. With dot. Then BC dot A plus A bar. Okay. So missing literal and their complements are taken. After that, what is done? These terms, expand each term, and then you have to again rewrite that, reorder the literals. F of ABC. Now you can apply that distributive law. What it is that? Here bracket it is there, so you can take the multiplication along with B and multiplication, then plus, and then multiplication along with B bar. So ACB plus ACB bar, right? Then ABC plus ABC bar, and then BCA plus BCA bar. Okay, once this is written, you can reorder the literals. Means if C is come first and B is there after that, then you can arrange according to the order of the literals. ABC plus AB bar C. So according to this is written. Now in this particular term, what you can see, there are some repeated terms. See, this ABC and this ABC, here it is 2 times. So you have to write only once. Okay, so this ABC, it is written once, plus AB bar C, okay, plus ABC bar and plus A bar BC. Okay, so in this way, this particular expression is written. So here you can see what is the standard form of this particular expression now. This is the standard form of this particular expression. How we have converted? First step, find the missing literals. Then take the AND of the product term with the missing literal and its plus its complement. Then expand each term and then reorder and then omit the repeated product terms. Okay. Have you understood this particular part, students? In that case also example it is there. This example you understood? Okay. In this in this particular expression, we have seen only one literal is missing, right? Okay, now if two literals are absent, see this next example. Convert the expression in the standard SOP form. Find the missing literal in each product term. The expression, it is given this, okay? This is the expression. F of ABC equal to A plus ABC. This is the SOP form, but in the first term here, you can see two literals are absent, right? Which are those? B and C. So B and C is missing. Now what you can do? Here you have to consider both the missing literals. So again, you have to take B plus B bar, C plus C bar, and then you have to take the ending of those along with A. So A dot B plus B bar dot C plus C bar. And this term is written as it is. Okay. Now, after that, how you will expand this? You can expand first with one bracket. So here it is written AB plus AB bar. Okay. And then C plus C bar, here it is written as it is. And after that, here it is written, then this will be again multiplied with this. Okay. So ABC, first AB will be multiplied with this C. Okay. Then AB will be multiplied with C bar. So ABC plus AB C bar. Then this term is taken and this will be multiplied with this. So AB bar C plus AB bar C bar. And this term is written as it is. Okay. Now here again you can see the repeated term. Okay. Those repeated terms are omitted and this final expression is written. Okay. Got it? Yes. Have you got it, these students? Understood this particular part if two literals are missing?
Yes, ma'am.
Okay. So see, all type of examples are given in the notes. Now this concept I told you, you have to just go through all the examples. Fine. How to convert from SOP to standard SOP. Fine. These are all the steps. Now in the same way, you have to convert from POS to standard POS. Okay. Steps to convert POS to standard POS. Again, step 1 is same. Find the missing literal in each sum term, if any. Then after that, again the reverse way. Here we have taken the complement of the missing literal and we are taking the ORing of those. Here you have to take the product of the missing literals, right? And then you have to add that along with the literals present in the term. So or each sum term having missing literals with terms formed by ending the literals and its complement. And then after that, expand the terms by applying the distributive law and reorder the literals in the sum terms. Then reduce the expression by omitting the repeated sum terms, if any, because A dot A equal to A, right? If two terms are same, you can write simply one term. Now convert the given expression to standard POS. Now this form is given. Okay, this is the POS form, right? Product of sum. Now for this product of sum, which one is missing? Here, this is the first term. Here A plus B it is there, so C is missing. Here A is missing and here B is missing, right? Now what you have to do? Next step, you have to OR the sum term with the missing literal and its complement. Now in this case, you have to take the product of missing literal and its complement. So here you can see this particular example, A plus B, right? Maybe this is not clearly visible to you. See, this is actually the bracket, okay? Plus this, in this bracket, C dot C bar is given. So which one is the missing literal? C. So what it is taken? C dot C bar means the complement of that missing literal and the complement, but you have to take a product of that. Okay. And then you have to add that along with this term. Okay. Or the sum term with the missing literal. Okay. Then B plus C plus A dot A bar. Here this is missing. So ORing with this term and then ORing with this term. Okay. So this is the second step. And then again you have to expand these terms. How you will expand? Now, here it is given. A plus B plus, you can apply this particular law. A plus BC equal to A plus B and A plus C. Right? In the same way here, A plus B plus C, right? And with this ORing of this, and this will be again odd with C bar. So A plus B plus C bar. But this dot it is there. Okay? You are multiplying. You have to apply this particular law. Okay? So A plus B plus C. This complete considered as a here term as a BC. Okay? C. So A plus B plus C, A plus B plus C bar, then B plus C plus A, and B plus, likewise here it is expanded. Okay. And then after that, reorder these terms, means write in a proper order. So this it is written, and after that here, wherever the repeated terms are there, those are omitted, and finally this expression it is written. So which one is the important step here? First three steps are very much important. Otherwise, you will get the incorrect expression at the end. Okay, first missing literal, that is very simple. But in the second case, in the second step, carefully you have to write that particular form in the correct way if it is a SOP or if it is a POS. Right? In the SOP here it is taken the ORing, right? Addition of the missing literals. Here it is taken the ending of the missing literal. Okay? And then it is added with the previous term that is present in the expression. Okay, now another example here it is given with the same way here. Two literals are absent, B and C. Same example with POS form, the previous expression, A dot A plus B plus C. Now here all these three literals are present, but here two are missing. So what you can do? A plus what? B bar dot B, right? Plus C dot C bar. So B is missing and C is missing. So the ending along with its complement that is taken. Okay, missing literal and its complement. Okay, so that it is taken missing literal dot its complement. So here it is taken, and then these terms are expanded with this A plus BC, A plus B, A plus C. Okay, and this particular form here, based on this, after expansion you will get A plus B, B dot B bar plus C, and then A plus B dot B bar plus C bar. Okay, it is divided in terms of these two. Okay, A plus, first this particular part is taken, and this likewise only A plus BP, BC. How you can write? A plus B and A plus C. So accordingly this particular form is written. Okay, so you have to use that particular law, and then after that you can omit the repeated sum terms. Okay, and then you will get this final expression. Fine. So likewise you have to solve these particular examples. Why I am showing on this? Because if I will take it on board, it will take some time. Okay, but if you not understood, I will take on that whiteboard this particular example. If you understood this, then we'll go for the next part. Otherwise, I will repeat this part again. Just tell me, students, have you understood this particular part?
Yes, ma'am.
Okay, so POS. Okay, in the POS forms you understood, right? So the expression, this example is given. What is given? Convert the given expression to standard POS. Now, first step is same. You have to find the missing literal. There are three terms are present. A plus B, B plus C, A plus C. Now, in these three terms, what you can see? In this, C is missing. In this term, A is missing. In this term, B is missing. Right? Now, once this part, first step is completed. What you can do? Next step. Or some term with missing literal dot its complement. Now just go for this next step. A plus B plus C dot C bar. Which one is missing? C. So what you have to take? You have to write that C and then complement of that, and you have to take the ending of those, means multiplication of those, right? You have to use the dot simply. C dot C bar and ORing with the previous term, because you have to hear or of some term with the missing literal, because this is a POS form, right? In the POS form, what you are doing always? Product of sum, right? So this is the reverse way you have to use here, product of sum. So here you have to take this term and you have to take the ORing with the previous term. Okay. This term we have added. Based on which concept we have added this term in this term? Because this is the missing literal. But we cannot take this missing literal. We have to take its complement. And when we are taking the complement, you have to use here dot. Okay. B plus C next. Which one is missing? A dot A bar. A is missing. So taken the because A dot A bar, what it is there? Can you tell me, students, what is mean by A dot A bar, or what is mean by C dot C bar? What will be the answer for this?
0.
Yes, 0, right? How you can say that A dot A bar equal to 0? Suppose A is 1, right? So what will be A bar? 0, right? 1 dot 0 means what? 0. A dot A bar. A dot A bar. Suppose A is 1. In that case, what will be A bar? 0. 1 dot 0 means what? 0. If we'll multiply 0 with any number, nothing will happen. So that's what we are using this term in the POS. Okay, got it? Now, tell me, what is the meaning of A plus A bar? Okay, 1. Suppose A is 1
1.
plus, what is A bar? 0. 1 plus 0. What is that? 1. Right? So we are using this term in the SOP form, right? We are taking the complement, but we are adding those. In the POS form, we are using this form where we are expecting this because we are adding with the previous term. Here we are ending with the previous term. So will be required 1, right? So in this case, here you can see plus, actually it is 0. C dot C bar means it is nothing but 0. But we want to expand it. After expansion, we'll get the standard form because we want to convert into standard form. So that's what this combination it is used here. Okay. But in the SOP, what you have seen? In the SOP form, here you can see B plus B bar. Means actually it is what? 1. So if we'll multiply AC dot 1, that is nothing but 1 actually. So this will be AC. Right? You got this concept, students? Why this particular term is written over here? Indirectly, this is nothing but the expansion of this. We are considering this term, it is nothing but it gives the 0 result. But we have to convert into standard POS form where all the literals will be present. So that's what we are taking this particular term. Okay. And then after that, expansion of this, expand the terms with using this particular law. A plus BC equal to A plus B, A plus C. Okay. So A plus B plus C. This term along with this first term. Okay. So A plus B plus C, this will be one term now. And after that, that will be this dot. Because of this dot, here it is nothing but this is the multiplication of these two terms. A plus B plus C dot A plus B plus C bar. Okay. Then B plus C plus A and B plus C plus A bar. Okay. Likewise, this expansion is done. You can use this particular distributive law for this. And then you have to reorder the terms. Here reorder is done and then omitted the repeated terms. So you will get the final expression. Got it? Yes, students? Have you understood? Yes?
Yes, ma'am.
Yes, sir.
This is already shared actually. On classroom, you are there? So on the classroom, I have shared the notes of the number system and Boolean algebra. This part comes under Boolean algebra. Fine. So you just go through complete. See now till this point, we have gone through all the points of SOP and POS. The first point that you have to read, I will just show you here in this particular notes. Here you can see. Here complete this Boolean algebra postulates are given. Okay. So here you can just go through this. See, completely here it is given. Just go through this. A plus A bar means 1. So why it is there? A plus A bar equal to 1. A dot A bar equal to 0. Since 0 dot. You just go through this. Complete. As per the syllabus, complete all the concepts are given here. Okay. All the laws, why this particular law is proved, how it is proved, this is also given in terms of truth table. Why I have not explained, it is not as specifically given in the syllabus. Okay, but wherever it is required, we'll take that particular part. Okay, so this part it is taken. You can just go through that. After that, SOP and POS. This is the important that it is required. See, standard representation of logical Boolean functions, right? Standard representation for logical Boolean function. This part we have seen in the PPT. In the form of PPTs also I will send you. So what is SOP? What is POS? Okay. This complete here it is given. Okay. Then standard SOP POS canonical form. These steps just now we have seen. Right. Converting, how to convert. And then after that, what is min term, max term? So these examples that already we have seen in the PPT, this particular table, here also it is given, variable, min term, max terms. Representing the logical expression using min term. We have seen this example also, right? In the last lecture, you have solved this particular. Okay, summation denotes, pi denotes. Okay, and this truth table, if you want to convert into SOP form, how it is converted. So this form is written. So too many examples are also given based on the truth table, how to convert into SOP POS form. Okay, few examples are also given. If expression is given, then how to convert, this is also given. How to write the truth table of this particular expression. Students, you have to do the practice because we don't have a time to cover all these concepts. Right? We have only 2 lectures and the syllabus is very much vast. Okay. And because of this, in between this current Diwali vacation, it's not possible to take all this one and each and every example in detail. So you do the practice wherever you are feeling a doubt, you can ask in during the lab also. We can take doubt solving during lab session also. Fine. Because once you understood that concept, you can solve the example in different ways. Yes. So, you can just go through this. Fine. Okay. I will not going into the depth of this part now. You can just go through this. Only 1-2 examples are given. After that, we'll start with the actual topic that is required for the logic minimization in the next part. Okay. In the next lecture. Fine. Very much practice is required for this particular subject. You have to do the practice, means you have to write it down on the book. Fine. So now I will take the attendance, answer your roll calls. A division first. जाते जाते Oh, madam. Hmm. Next, 22. Please pay attention and call your roll numbers. 23.
Ma'am, 22 present.
Fastly you call your roll number, students. 23, then 24, 23 absent. Next. 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 Next, 60. Next. Hmm. 69 absent. 69 is absent. Next. 71. Okay. Okay. Next, B division. A division you can
1,
leave. Hmm.
2,
3,
4,
5,
Next. 6.
7,
8. 8.
Next. Fastly.
10, 10,
11,
12,
13,
14,
15,
16,
17,
18,
19,
20,
21,
22.
23, 24. If you will not call, no, I will mark as absent. Otherwise, place in a chat box. Next.
25,
26,
27. 28.
29,
30,
31.
32,
33,
Next.
35,
34
36,
absent. Next.
36,
Hmm.
38,
Next.
39,
40,
41,
43,
45,
Next.
46.
47,
48.
49,
51.
Next. Next. Call next.
52.
Hmm. Next. 4.
Present, ma'am. 54.
55.
56.
57.
Next.
59.
Next.
61.
62.
63.
64.
Next. 66.
66. 67.
70.
Present, ma'am.
72.
70.
Next.
72.
I'm calling roll numbers. Just check. Absent 6, 9. B division 6, 9, 23, 24, 50, 53, 58, 65, 69. Okay. Okay, students. Fine. You can leave. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.